I'll come back. So I'm just going to read through a little bit of this with you, then I'm going to leave you to read the rest of it rather than me just reading through it. But you'll see there are a few just a few corrections to this, a couple of typos that are in here. So fusion happens all the time in the sun, but that's because the sun has really, really high temperature, really, really high pressure. So that gives the sun enough energy for fusion to actually happen. For fusion to happen on Earth, so for fusion power stations and things like that, there are some very difficult conditions to meet. So we need to have very high temperature. We need to have very high temperature. That's quite difficult. So the first paragraph here, nuclear fusion in atomic weapons. So fusion has been successfully achieved with the hydrogen bomb. However, this is an uncontrolled fusion reaction, and the key to using fusion as an energy source is control. So in a hydrogen bomb, two isotopes of hydrogen, deuterium and tritium. So remember, hydrogen has the same number, isotopes have the same number of protons but different number of neutrons, are fused to form a nucleus of a helium and a neutron. So deuterium is an isotope of hydrogen with, normal hydrogen has one proton, okay, and that is it. Okay, so the mass number is 1 because there's just one proton in there, so 1 plus 0 is 1. Deuterium has one neutron, so it's got one more neutron than normal hydrogen, and it's got one proton. So deuterium, the mass number is 2 because it's one neutron plus one proton, but it's still one proton. Okay. Deuterium is often called heavy hydrogen. Tritium is another hydrogen isotope, which is called super heavy hydrogen sometimes, and it actually has 2 neutrons, so not 3 protons as it is in the notes. That's rubbish. It's still got 1 proton, but 2 neutrons. So the mass number is 2 neutrons plus 1 proton, 3. And still the proton number, the atomic number, is still 1 because it's still hydrogen. Deuterium is actually naturally occurring in seawater, so it's actually really easy to get. And tritium can be made from lithium, which is readily available on Earth. So actually, the raw ingredients for fusion are very easy to get, and they actually produce helium, which is a safe product to produce this energy. So fusion, in theory, is really, really good because we've got the raw ingredients for it relatively easily. They're not radioactive. And also, it produces helium, which is not radioactive. So where fission produces radioactive waste, fusion would not. However, it's very difficult to do fusion. So if we could harness fusion as a power supply, it would be ideal and it would solve a lot of the world's problems. But it's harnessing it that's the problem. So I'm going to link you a video as well, this video here, which is quite an interesting video. But I want you to read through the rest of the booklet yourself and then watch the video as well. Okay.